Good morning, this is Mrs. Merrill, and today we're going to be talking about Learning Target Objective 7.2, which is Properties, Laws of Parallelograms. So to begin this morning, let's look at the definition of a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Please remember when we're going to mark this in a diagram, we have to use some sort of arrows to indicate which side is parallel to which side. So you can see that we use the arrows in the diagram above to show us that the opposite sides are parallel. We also use the symbol, which looks just like a little parallelogram, to say that the shape is a parallelogram. So you see there that we say in this symbol, PQRS is read parallelogram PQRS. Now we're going to look at some laws that we have that tell us about characteristics or properties of parallelograms. On your note template, you will see a place to write each of these laws. And then what we're going to do, we're going to apply these laws to solve for unknowns, unknown sides, unknown segments, unknown angles in parallelograms. The first law is Theorem 7.3. It says, if we know the shape is a parallelogram, then we also know that the opposite sides are congruent, meaning that the opposite sides are the same length. In this picture, segment QR is the same exact size as segment PS. Notice the one tick mark. And then also, segment QP would be the exact same size as segment RS. Again, notice the double tick marks. Here we have the Theorem 7.4. Again, it is another law that we're going to apply to solve for missing parts in parallelograms. The law says if we know that the quadrilateral is a parallelogram, then we also know that the opposite angles are congruent, meaning that the opposite angles measure the exact same size. So in this picture, you can see angle Q and angle S marked in there with the one angle marking are the exact same size. And likewise, angle P and angle R would be the exact same size. Notice they're marked in with the two markings. The congruent angles have to have identical markings. Here we have our next law that you want to write in your note template. This is the Theorem 7.5. It says that, again, if we know that the shape is a parallelogram, then we know that the consecutive angles are supplementary. Now that means the angles that are right next to each other add to 180 degrees. In the picture that you see on your screen, angle P and angle S would have to add up to 180 degrees. In other words, their angle measures would add up to 180 degrees. Say, for example, angle P might be 80 degrees, and then angle S might be 100 degrees, and 80 plus 100 would be 180. Now, also in the picture, any of the consecutive angles must add up to 180 degrees. In other words, angle Q and angle P would have to add up to 180. Angle Q and angle R, see they're beside each other, the top, they would have to add to 180, their angle measures. And then angle R and angle S, their measures would also have to add to 180 degrees. Our next law, Theorem 7.7, talks about the diagonals of a parallelogram. Now, remember what a diagonal is. A diagonal of a polygon connects non-consecutive vertices. In this case, with a parallelogram, it's going to connect opposite vertices. So in this picture, we have two diagonals, diagonal QS, and then we have diagonal PR. Notice in the picture, the diagonals cross, and when they do so, or they intersect, and when they do so, they cut each other into half. In other words, you'll notice by the tick marks, the segments of the diagonals are congruent. Notice the one tick marks and the two tick marks. So we have, if the intersection is M, then we have QM is the exact same size as SM, and PM would be the exact same size as RM. Our next law, Theorem 7.8, says that if we have a parallelogram, in other words, if the quadrilateral is a parallelogram, then if one of the diagonals are drawn in, that diagonal will separate the parallelogram into two congruent triangles. In the picture, we have the top triangle, ABD, congruent to the bottom triangle, CDB. So a diagonal of a parallelogram will divide that parallelogram into two congruent triangles. Now, we've got a couple examples here of applications of the laws that we just talked about. In other words, what we have to know now when we start analyzing diagrams, we have to look at the picture and think about applying those laws. What are we applying? Well, opposite sides of a parallelogram are congruent. Opposite angles in a parallelogram are congruent. Diagonals in a parallelogram bisect each other, it means cuts them in half into two equal parts. And consecutive angles, in other words, angles that are side by side in a parallelogram, must sum to 180 degrees. In other words, their angle measures add up to 180 degrees. So let's take a look at this first example. You'll notice that segment FG is 5. You'll need to mark that in on your note template, so please mark in segment FG is 5. And then also please mark in on your note template that segment GK is 3 units. All right, so then the question, if this is a parallelogram, we have to find the lengths of two unknowns. They want us to find the length of the segment JH, and they want us to find the length of the segment JK. Now think about that for a second. Do you see a law that you just wrote on your note template that you could apply in each of these questions, A and B? Write down your answer. What do you think GH is and why? Notice it says explain your reasoning. And then write down, please, what you think JK is. And again, explain your reasoning. And here are your answers. In the diagram, notice that FG is an opposite side to JH. And what do we know? We know opposite sides of a parallelogram are congruent, so that makes it 5. So that makes FG 5, so therefore JH is 5. All right, now let's take a look at the second part. We know that in here we know that GK is 3. So then if we substitute in, we know that JK also has to be 3. Again, we know that diagonals bisect. All right, let's try another one. Here we have a parallelogram, PQRS. Notice the opposite sides are parallel, marked in with the arrows. And we need to find the measure of angles. All right, so we're needing to find the measure of the angle R, and we're needing to find the measure of the angle Q. All right, think about that a second. See if there's any laws that you can think up that we wrote down on our note template that might apply here to help us solve for the measure of those angles. All right, let's take a look at the first example. Let's look at letter A. We need to find the measure of angle R. But what do you know about angle R and angle P? They're opposite angles, right? And what do we know? What have we written on our note template? What do we know about opposite angles of a parallelogram? Well, we know they're congruent. So if I substitute in, I know that angle R has to be 70. Opposite angles of a parallelogram are the exact same size. All right, now let's check your answer on B. All right, well, on B, what do we know about angle P and angle Q? What's the relationship there between those consecutive angles or the side-by-side angles? What do we know about those? Well, remember our law? It said consecutive angles in a parallelogram are supplementary, which means they add up to 180 degrees. So I just simply write down angle Q plus angle P has to add to 180. Again, it's a parallelogram, and consecutive angles must be supplementary. They must add to 180. Basically, what I'm doing is subtracting 70 from 180 degrees. And I come up with my answer of 110. Okay, now I want to take a look at an example here. It's a real life story problem. It is not on your note template, but I wanted you to kind of look at it and kind of get an idea of how this might possibly be used in real life. So it says a drafting table is made so that the legs can be joined in different ways to change the slope of the drawing surface. In other words, you want to raise it up or down. In the arrangement below, the legs AC and BD do not bisect each other. So is ABCD a parallelogram? Now think about that. In other words, what they're saying is that those diagonals do not cut each other into two congruent parts. So is the shape ABCD a parallelogram? Think about it a minute. And of course, the answer is no. If it were a parallelogram, then all of those laws that we talked about in today's lesson have to be true. So if any of the laws aren't true, in this case, the diagonals are not bisecting, so there is no way it could be a parallelogram. What we learned today is that if it's a parallelogram, all of those things must be true. In other words, opposite sides must be parallel, opposite sides must be congruent, opposite angles must be congruent, the diagonals must bisect each other, and we know that a diagonal will bisect or will cut the shape into two congruent parts, and we also know that the consecutive angles must be supplementary. So all those things must be true. All right, well, that's it for today. Thanks so much for watching.